Hello everyone, welcome back to my channel. In the previous video, we learned how ChatGPT generates response one token at a time. But we skipped the most important part of the entire process, that is transformer. You may heard people say that ChatGPT is based on the transformer architecture. But what exactly is a transformer? And why did it completely change the field of AI? And why are almost all modern LLM models built on top of it? In this video, I'll explain the transformer from scratch using simple examples and animations. Why do we need transformers? Before transformers, researchers mainly used RNN networks and LSTMs. These models processed word one by one. Imagine, suppose you are reading a book, okay? You read the first word, then the second, then the third, until you reach the last word, correct? So that's exactly how a RNN works. While these approaches work for short sentences, struggle with the long ones. The model gradually forgets the important information from the beginning of the sentence. Then only training is also slow because each word must wait for the previous one to finish. Correct. So researchers wanted something faster and better. That's where the transformer comes in. Suppose let's take an example. The cat sat on the mat because it was tired. Okay. Very simple sentence. Now, what does the word here IT refers to? Is it referring to the mat or the cat? As a humans, we instantly know or we understand that it refers to the cat, correct? So the transformers learn to do something similar. Instead of reading words one after another, it looks at the entire sentence at once and it decides which words are important for understanding every other word. So now this is the transformers architecture which basically introduced in the famous research paper, which is attention is all you need. I'll give that paper in that description. You will find that link. You guys can read from there. Okay. So, but remember, every LLM is inspired by this architecture. Today, we will understand each and every component of this architecture. So let's first look at what is embedding. The first step is converting every words into vectors. We discussed this briefly in the previous video, if you guys remember, right? So every word becomes a list of numbers and these numbers basically capturing meaning. Similar words produce similar vectors. Suppose let's take an example, king, queen, prince, princess. So if you see these vectors, these words and their vectors are mathematically close to one another. Now, in simple terms, let's understand positional encoding. Let's say if I shuffle these words, what will happen? Okay, dog bites man. Okay, now if I shuffle these words, it will become something like man bites dog. Correct? Or same words you can see, right? Basically, there is some same words. So now, but when I change, when I shuffle these words, it's completely means create a different meaning, right? So, like this way, since the transformer processes all words simultaneously, it does not naturally know their order. So, positional encoding basically solves this problem. It tells the model where every word appears in the sentence. So, now the model understands both the meaning of each word and its positional. Let's see about self-attention. Now we reach the heart of the transformer. Self-attention. Suppose we have this sentence. The animal did not cross the road because it was tired. What does it refer to? The transformer compared it with every other word in the sentence. It calculates how strongly each word is related. Now if we say words with higher relevance receive more attention. Okay, so eventually the model correctly identifies that it refers to the animal. So this is the ability to focus relevant words is called self-attention. You can simply say in simple words that some word in a sentence we are giving some higher priority to understand the whole sentence. So it is one of the biggest reasons why transformer outperform older models like RNN or LSTMs. Now let's see what is multi-head attention. Shows several attention heads, but one attention mechanism is not enough, correct? So the transformer uses multiple attention heads simultaneously. Think of it like a team of experts. Suppose one expert is focuses on grammar, another is focuses on meaning, Another identifies relationships, try to understand the relationship between the subject and verbs, right? And another one understand long range dependencies. At the end of all these, experts combine their knowledge and provide us the result or the responses. Now let's talk about feed-forward network. After attention, every word passes through a small neural network. These networks learn even more complex patterns. Think of attention as identifying the important information, while the FFN means feed-forward network transforms the information into a richer representations. Now let's talk about residual connection. Deep neural networks are difficult to train. Information can disappear as it passes through many layers. Correct. Residual correction just solve this problem. Instead of replacing the information, it basically add the original input back into the output. This helps preserve the important information and makes the training much more stable. Now let's see about the layer normalization. After every major operation, this model performs layer normalizations. This keeps the value balanced. You can think of it like maintaining a healthy range so that no value becomes too large or too small. And this basically improves the training stability of our models. Now, if you see this diagram, you can understand that one transformer layer is not enough. Modern language models stack dozens of these layers. Suppose like if you see that GPT-2 or GPT-3, they have multiple layers, correct? And newer models becomes even deeper. Each additional layer gradually builds a richer understanding of the language. So now you can see this is the complete journey. A sentence enters the model, every word becomes a vector, correct? And positional information is added, and self-attention determines which word matters. And feed-forward networks enrich that representation basically. And residual connection preserves those information, and layer normalization establishes the training. Conversation, you are now understand the high-level architecture behind every modern LLMs. In the next episode, we will try to deep dive much deeper into self-attention, and we will learn how these queries, keys, and values work, and why that make transformers so powerful. Guys, if you found this video helpful, consider subscribing to KM for more videos on artificial intelligence, machine learning, and LLMs. Thank you for watching, and I will see you in the next video.